Nope.
Yes.
So, volumes of pyramids and cones. That's what happens when you get to be ancient.
Yeah.
So, the volume of any cone or pyramid with base area capital B and height h is given by this formula. The volume is 1/3 area of the base times the height, as we showed with both the water and with the wooden pyramids. Okay? So you just have to remember it's 1/3 area of the base times the height. Please don't just say 1/3 base times height. Base is a length. Capital B is area of the base. Not the same thing. Same letter, but a capital letter, not a lowercase letter, so it means something different. So let's start with this one. Let's find the volume of the cone. I still start this by working with the base. The area of the base is going to be pi times the radius squared. So that's pi times 10 squared is 100 pi. Then the volume is 1/3 of the area of the base times the height. So this is going to be 1/3 of 100 pi times, well, they didn't give us the height, but it's 24. How'd you get that? Right, it's a 5, 12, 13 triangle doubled, so that's 24. So this is exactly 800 pi cubic meters.
Did you have the, not half, yeah, half.
I took 1/3 of the 24.
Okay, not the 100.
Yeah, because taking 1/3 of 100 gives you a nasty decimal. But taking 1/3 of 24 is, pardon?
It gives you 8.
Right. And then 8 times 100 is 800.
Okay.
Yes?
May I go to the restroom, please?
You may. All right. For the next one, find the volume of a regular hexagonal pyramid. Joey, please put it away. Find the volume of a regular hexagonal pyramid with base edges 10 inches and height 16 inches. So, the base is a hexagon. On all these problems, I deal with the base first. The base edges are 10 inches. So I know the perimeter of the base is 6 times 10 is 60. To find the area of the base, what formula will we use?
1/2 A times P.
And A stands for what? And P stands for? Yeah, very good. Apothem, apothem, doesn't matter. So we know the perimeter, but we don't know the apothem yet. So we'll draw this in. The apothem splits this in half, so each of these is 5. The apothem also splits the central angle, which was 60 in half, so this is 30. So real quickly, you can find that the apothem is 5 square roots of 3. So that's 1/2 of 5 square roots of 3 times the perimeter, which is 60. Again, I won't take half of the 5, I'll take half of the 60, which is 30, times 5 is 150. So it's 150 square roots of 3 for the area of the base. Then the volume is 1/3 the area of the base times the height of my pyramid. So it's 1/3 of 150 square roots of 3 times the height is 16. 1/3 of 150 is 50. 50 times 16 is 800. So it's 800 square root of 3 cubic inches. Okay.
Could you write cubic inches? Like, could you write cubic inches?
If you want to. Either way is fine. In some ways, I like writing it out as cubic inches better than writing inches to the third because it's like inches to the third power. What does that mean? But it kind of makes sense because it's inches times inches times inches. All right. We will do some composite figures with these. The nice thing is that with composite figures and volume, it is always simply adding or subtracting volumes. If they're stuck together, you add their volumes together. If one of them is bored out of the other one, removed from one, you just take the volume of the bigger minus the volume of the smaller. Surface area is always the one you have to think about before you start just finding it. Surface areas for composite figures are never surface area of one plus the surface area of the other, or surface area of one minus the surface area of the other. Whereas with volume, with composite figures, it's always volume plus volume or volume minus volume. Question?
If you have a sphere,
Yeah, we haven't gotten to spheres yet, but we will. All right, so let's find the volume. So for both of these, we need the area of the base, and it's the same base for both. So we'll do base times height of the base. So it's 20 times 16 is 320. And I tend to mark them like this. This is the volume of the pyramid. So it's going to be 1/3 of the area of the base times the height of the pyramid. So it's 1/3 of 320 times 21. Let's see, 1/3 of 21 is 7. So that's 2100 plus another, so 2240, I think. Someone double check me on that, but I think that's correct. And then the volume of the prism is just area of the base times the height, because it goes straight up and down. Every layer is the same. So that's going to be 320 times 28. I'm getting off this train now. I don't know how, I'm not doing that in my head quickly. No one's got their calculator out? Well, how much? 8,960. So then the volume is just 2240 plus 8960, which is 11200 inches cubed. Questions about that?
Why was it base times height? Oh.
Because it's a prism, and every layer is the same. With a pyramid, right, as you go up, every layer gets smaller. All right, let's take a look at this one. We don't see a lot of problems like this, but sometimes you do. This is called an oblique cone because it leans to the side.
Does that make a difference?
Not really. Finding the surface area for this is very difficult. Finding the volume, no big deal.
Do you surface area for these?
I'm sorry?
Do we have to do surface area?
No.
Yes.
Are you sure it's not going to be like a bonus on a test where you're like, only one person gets this every year?
Wow. I should just stop giving bonuses at all.
No,
Man.
I do it.
If that is going to be a question for the bonus.
No, your bonus will not be anything about finding the surface area of an oblique
Okay.
cone. Yes.
Why is it hard to find the surface area of that? Wouldn't it be like?
Because the slant height changes depending on where you are on the cone.
So it changes.
Like over here, this slant height is way bigger than this slant height. So since the slant height is not constant, I'm not even sure how to do it quite. I have some ideas, but I think it might involve some calculus.
Oh,
I don't like
they
that.
don't like that.
so I won't make you do it right now.
I want to go into like normal.
Right
math,
now.
calculus happens.
Or pass.
So again, we'll start with the base. So the area of the base is pi times the radius squared. So it's pi times 6 squared is 36 pi.
Where is this?
And then the volume is 1/3 of the area of the base times the height. So it'd be 1/3 times the area of the base, which is 36 pi. And what is the height of this? 20. Not the 26. This, by the way, in this case is called the axis of the cone because it goes from the vertex down to the center of the base. So let's see, that'd be 12 times 20 is 240 pi cubic feet.
I forgot it was a third.
Pardon? You forgot the 1/3?
Well, I did 360 because I thought it was half.
So yeah, that's not good. All right.
Next problem.
Is this the last one? Yeah.
Yes.
Indeed.
Okay. So again, we'll start with the base. The area of the base is going to be base times height of the base. So that's 18 times 18. You guys all know that, right? 1. Gosh.
2, 3, 324.
324.
Yeah, that's what I'm talking about. Got the wrongest answer on that, but I can do this.
Eventually.
Yeah, it was my third try.
So then the volume is 1/3 of the area of the base times the height. So it'd be 1/3 times 324. And this is where people sometimes go, oh, times 12. Is that the height?
No.
No, that's the slant height.
Idiot.
I'm
kidding.
So we want to find the height. Well, the height should come right down the middle of the deal
So 9
and make a right angle here.
12.
In this particular case,
Let's go. It's not a 3, 4, 5. I thought it was.
this is going to be 9 because it's halfway across, right?
Yes.
If it's a hexagon, that's not going to be half the side. You're going to have to figure it out. It's always going to be the apothem of the base because it goes from the center perpendicular to the side. Okay? So that's 9, and it would have been nice if it was a 3, 4, 5, but not so much.
I was hoping. I was like, oh my goodness, it's so easy. No, it's not so easy.
Wishful thinking.
So we'll do 9 squared plus the height squared is 12 squared. So it's 81 plus h squared is 144. So h is the square root of what, 63? Which simplifies to 3 square roots of 7. In case you're wondering, how did he do that so fast? Well, 9 is a perfect square and it divides evenly into 63. The square root of 9 is 3, and 9 goes into 63 7 times. So this would be times 3 square roots of 7. And the really nice thing is the 1/3 times the 3 is just 1. Yeah, so it's just 1. So this is 324 square roots of 7 cubic centimeters. All right, any other questions? Yes, ma'am.
When did you want to do math?
When did I want to do math?
Yeah, like
Usually
forever.
after